Hello and welcome to episode 1 of Kyle Codes. Today I picked a problem from LeetCode.com. It's just a simple problem. Oops. Go away. Okay, it's just a simple problem. The problem is, given an array of integers, return indices of the two numbers such that they add up to a specific target number. You may assume that each input would have exactly one solution, and you may not use the same element twice. Alright, so let's just jump right into it. Let's start defining things. So we have an array of integers, so let's define that. Int array, say numbers, or integers. Integer array equals new integer array, and we'll do an array initialization. Okay, let's use the example 2, 7, 11, 15. Alright, and then they add up to a specific target, so let's define our target integer target, and for the example they use 9, so let's just define some stuff. We need to return two indices, index 1, int index 1 is going to be, let's just leave it, and index 2. Okay, so the first thing that comes to mind in terms of algorithm is we just go through each number and look at the other numbers if they add up to our target, done. Let's say we're done. If they don't, just keep going. So this is a pretty simple algorithm to solve this. It should give us the right answer. Okay, so when we say go through each number, that basically tells us we need to use a for loop or while loop or some kind of looping. So let's do that. And I'm going to separate this out. I'm not sure if that'll be necessary, but let's try that. For int I equals 0, I is less than integer array.length. Okay. Alright, now we're going to look at the other numbers. So, because we're looking at the other numbers, that means another for loop. So let's do that. Let's use j as our second index, enumerator or whatever. J is less than integer array.length plus j. Okay, so we're looping through each number, and then we're also looping through every other number, and we'll worry about this in a bit. Okay, now I want to look at this. This means we're going to go through every number in the array, but that's not necessary because the very last number doesn't matter, because if we get to the very last number, there's no numbers after it, so we know that we won't find a solution. So we're going to go to integer array length minus 1. Now, in addition, we've already compared, so this is our first number, and we're comparing it to every other number, but we only need to look at numbers that come after it, because we've already done comparisons for the numbers before it. So for example, let's do this down here. Let's say draw our array. Okay, so if we're looking at 2 as our number, our target number. The other numbers we're going to look at are 7, then 11, then 15. If we're looking at 7, well, we've already looked at 2, so we don't need to look at 2 again. We can just look at the numbers that come after. So we go 7, 11, 15. And then we can look at 11. And then the only other number that we haven't checked the sum of yet is 11 and 15. Because we've done 7 plus 11, we've done 7 plus 15, 2 plus 7, 2 plus 11, 2 plus 15. Okay, so what that means for us up here is when we're doing the j, we can initially set j to I plus 1. Okay. So, let's check the comparison. If integer array I plus integer array j equals our target, let's set our indices. Index 1 equals I, index 2 equals j. Okay, if they don't, keep going. So once we are here, we don't need to keep going. So we can break out of the for loop. So we'll just break. Now, that's only going to break out of this one. Let's say we want to break out of this one too, because there's no reason to keep going. Because we know there's only one solution according to the problem. You may assume that each input would have exactly one solution. Alright. So, how do we know if we should break out of the second for loop? Well, we can check index 1 and index 2 to see if they have values. So let's set an initial escape value that should never be in the array. So that's going to be -1. That's a good one, because they're all positive integers. Okay, so we can say if index 1 does not equal -1, break out of this for loop as well. And if it does, keep going. Okay, so now we're here. Okay, check if a match was found. Alright, so we can check again if the index is not -1. So if it's not 1, we found it. Found a match. If it is -1, no match. So let's just let's see. Okay, the problem has its return an array of integers and put it in a function. All right, let's do that later. So okay, 2 numbers, so we only need an integer. Let's just do a okay. Well, you know what? Let's just refactor it so it kind of fits to the parameters that they gave us. So let's create a new function that they want us to fill out. Let's use that. Okay, so I'm just gonna put all this code in here and change the names. We are using integer array for our name. Let's use nums, which is what they use. Target, we use the same name, so we don't have to change that. Okay. Now they want to return an integer array, which is our indices. So let's do that. Integer array. Let's call it result equals new integer array 2. Well, let's just for now set it to null. And then at the end we will return result And we don't have to do this anymore. Okay, so now we have our result. Let's remove these. Index 1. Okay, so if we do find a result, let's construct our result array here. Use an array initializer, and we'll do I and j. Those are our indices. Okay, and we could just say, now we have a result of null, an initial result of null, so we could check against that instead of checking -1. We can delete this code, delete our diagram. Okay, now we'll call our function. What's it called? ToSum. ToSum nums. Integer array is our numbers. Target. And then the result is a int array. Let's say we'll call it. I'll just call it result. Equals that. And we'll do some output. If result is not equal null, we found a match. Else, no match. So let's do that. Found match. Else, no match. Okay, so if we found a match, let's just, for now, let's just write it to the console. Use a string format. And we can say found match. We'll put up 2 indices. And if no match, console.writeLine. No match. Now, to be safe, we could do some checks in here, such as checking if, because we use 2 indices here, we should, after checking if it's null, we should check that the length is greater than 1, since we use 2 elements of it. We don't want to cause an exception there. Looks good, looks good. Could do some other stuff in here, like check if our input is null. Let's add that, just to be safe. If nums is not equal null. Okay. Because that could cause an exception. If it is null, we just want to return result of null, which is good. That's correct. Go through each number. Okay. Another thing here is this could be an out of bounds exception. If I plus 1 is outside of the array, could happen right there. But I'm not worried about that. Okay, so let's run it and see if it works, if it gives us the correct answer for this. Alright. Oh, I should probably put a breakpoint right here. Let's put a breakpoint. Okay. Let me show the console. Okay, and you can see it says found match 0 and 1, which is the correct solution that they gave us in the problem. Return 0, 1. So it looks good. We could test it with a couple other examples, but I think it's probably good. Alright, so that is the brute force solution. So there's a couple improvements we could do to make it faster. You can make it search faster. And I actually found this by reading the hints, so let's look at that. Let's look at hint 1. This is really brute force way would be to search for all possible pairs of numbers, but that would be too slow. Again, it's best to try out brute force solutions for just for completeness. It is from these brute force solutions you can come up with optimizations. Okay, so that's what we did. We started with a brute force solution, which is just comparing every set of numbers. Oops. Okay, let's look at hint 2, maybe an optimization. All right, so if we fix one of the numbers, say x, we have to scan the entire array to find the next number, which is value minus x. Where value is the input parameter, can we change our array somehow so that this search becomes faster? So what I think they're talking about, I could be wrong, is they want to use a binary search. And the way you use a binary search is by sorting an array. So if we sorted the array, then we would only have to use one for loop, because right here you see we go through 1, we set that as our x value, they're calling it, and then instead of scanning, which this is scanning the entire array, we can just do a binary search on the sorted array. And maybe we'll do that next time. Yeah, maybe we'll do that next time. Okay. So hint 3, let's look at hint 3. The second train of thought is, without changing the array, can we use additional space somehow, like maybe a hash map to speed up the search? So that's something we could do as well. We could use a C# dictionary, which is it would be a mapping between, it'd be like dictionary, dictionary, it would be a mapping between an int and an int, which would be, we'd probably call it something like value to index map, something like that. And we just fill that out. So we fill that out before doing any processing. And then we can kind of do the same thing they were talking about in hint 2, where we fix our value, so we do one iteration and look through each number, and then we know that our y value, which is the next number we need, is value minus x. So we could just search our hash table for that value, which would be much faster than I think either of the previous ways. So maybe we'll do that next time as well. Okay. Yes, let's stop for now. This is the end of Kyle Codes episode 1, and let's do those other solutions next time. Thank you. Goodbye.